All right, so here we're going to talk about the Z statistic has approximately a standard normal distribution and p-values, and we're going to talk about one sample Z test for a proportion, so when we have a one sample test. What's going on here is that we're going to do the same thing that we've been doing. Remember, this is the statistic minus the parameter over the standard deviation of the statistic, and they're using p-naught because they're telling you that the p came from the hypothesized value, right? And then define the p-value by calculating the probability of getting a Z statistic this large or larger in the direction of the alternative. So when we have that our p is greater than our p-naught, right? So when our proportion is greater, notice that this symbol is kind of pointing in this direction, and we know that we're going to shade this way. And if it's pointing in this way, then we're going to shade this way. Both of these are one-sided tests here. You're dealing with a one-sided test. Both of these right here are one-sided. And those are easy, and that's great, and you just find this p-value, and you're good to go, right? The problem only comes in when we have a not equal to sign. This makes it a two-sided test, and which means that we actually have to find the value we got or something more extreme going this direction and this direction, which means I have to find the p-value, and I can find it for only one side, but, okay, the big deal here is that you must double that p-value you get. Double the p-value to get the real p-value. So I'm going to get a p-value here, value of getting this sample statistic or something more extreme, but I also need it for this side of the graph too. This plus this one, both of these together give you the actual p-value. All right, so whatever I get under the curve here, I have to double it. You must double it when I have a two-sided test. All right, so everybody hear me, when I have a two-sided test, you're going to have to double it. Don't pretend like you didn't hear me and you made that mistake. Do whatever you need to in order to make note of that. All right, and then they tell you, use this test only when expected numbers of successes and failures are at least 10. This is the normal condition. All right, this right here that they're telling you is the normal condition. So you use it only when the normal condition is met. All right, so let's do this example. 1 potato, 2 potato. A potato chip producer has just received a truckload of potatoes from its main supplier. If the producer determines that more than 8% of the potato shipment have blemishes, the truck will be sent away to get another load from the supplier. A supervisor selects a random sample of 500 potatoes from the truck. An inspection reveals that 47 of the potatoes have blemishes. Carry out a significance test at an alpha level of 0.1 significance level. What should the producer conclude? All right, so we need to make sure that we first do our state. So we're going to perform a test at the significance level of 0.1. Here's our null and our alternative. The null is that p is equal to 0.08. The alternative is that it's greater than 0.08. If it's greater than that, that's when we're going to have to send them away. And P is the actual proportion of potatoes in the shipment with blemishes. That's what we're actually counting. So you have to state the significance level, the null and the alternative, and you have to tell me the parameter of interest. All right? So once you've done all that, you're done with your state step. Now plan, you're going to say if conditions are met, we should do a one sample Z test for the population proportion. So you have to tell me, the new thing in the plan is that you're going to tell me actually what you're going to do, that we're going to do a one sample Z test if my conditions are met. We're going to check the random, we're going to check normal, okay, so this is the n times p naught. Notice that every time we use p, we use the p from the hypothesized value, not the p from the sample. All right, because the p naught, p from the population is 0.08. P hat is 47 out of 500. Make sure you're using this one right here when you're checking your conditions. All right, I don't want you to get that confused. So we're using 0.08 and we check our conditions, and then we're going to assume there's at least 5,000 potatoes in the shipment because we sample without replacement, so our 10% condition rule applies. Now we're on to the do part. The sample proportion of the blemishes is p hat, which equals the 0.47 over 500. So remember that our Z statistic, our test statistic, like according to the green sheet, it says take the statistic minus the parameter over the standard deviation of the statistic. So what happens is that we're actually dealing with P, so my statistic is P hat minus my parameter, which is P, over the standard deviation of the statistic, which says take my P times 1 minus my P over my N. Alright, so over to the side, besides the fact having P hat is 47 over 500, I would also have my P written, which is 0.08, and then I would have my sample size of 500 written over here as well. This is the information I need in order to plug it into the formula correctly. So I'm going to take 47 over 500 minus 0.08 over the square root of 0.08 times 0.92 all over 500. And this is plugging it in, okay? So this is what I'm going to get, or what I'm going to put into the calculator to make sure. Try to not round if all possible. Do not truncate around, keep your decimals until you get all the way to the end. So they show you this is where it comes from, and they get this test statistic right here to be 1.15. This is what we got from our sample, right? Now we have to compare it to the normal. So to get the p-value, remember we're going to have a normal curve here. Well, what are the mean and standard deviation on my normal curve? Well, because it's a test statistic, it's standardized, right? It's 0 and 1, right? I standardized this. This is standardized test statistic. So what's the probability of getting 1.15 or something more extreme? Well, my p-value comes out to be 0.1251. Remember, you can use the normal CDF on here, all right? So, and then we conclude, since our p-value is 0.1251 is greater than the chosen significance level of 0.1, we fail to reject H0. There is not sufficient evidence to conclude that the shipment contains more than 8% blemished potatoes. The producer will use this truckload of potatoes to make potato chips. And so you're going to conclude just like that.